Welcome back, guys. Today I'll be doing graphs where I'll be plotting and also solving an equation graphically. Let's get started. Here I'm going to plot the graphs on the same graph paper using the software that I have instead of a graph paper. Part 1 has y equal 3 to the x minus 1 minus 5 for x is greater than or equal to -1 but lesser than or equal to 5. And the next one is y is equal to x squared plus 2x for x is greater than or equal to -1 but lesser than or equal to 5. Now this is the range that's given. So this is telling me the x values that should be in my table. So we have -1, 0, 1, 2, 3, 4, 5. So both tables will be having the same range because that's what's given. So now I'm going to replace here the x values. So I have 3 to the power x, take away 1 minus 5. When x equals -1, that's the first x value, I will have 3 minus 1 minus 1, that is 3 to the -2. Then minus 5. 3 to the -2, if you don't have your calculator to just work it out, is the same thing as 1 over 3 squared, which is the same thing as 1 over 9. So in other words, we have 1 over 9 minus 5. That would be giving me -4 and 8 over 9. You now can calculate this. So you'd have 1 over 9 minus 5. You can also have it as decimal, which is -4.9. So for -1, I'll have -4.9. When x is 0, let's do that one. So I'm going to erase this and replace x to be 0. So it means 0 will be here. So I will have 0 minus 1, which is -1. If you have your calculator, you could work this out. Or rewrite 3 to the -1 as 1 over 3 minus 5. And that would give me -4. And then that will be 2 over 3. Which is the same as -4.7. So I'm going to have this as -4.7. The next one, let's look at the next one. It's when x is 1. So instead of having 0, I am going to have a 1 here. So I have 1 minus 1, that's 0. Anything raised to the power 0 is 1. So 1 minus 5, I will have -4. So this will be -4. So if you realize, that is why I use 1 decimal place. Because here, this is -4.9. If we had rounded it off, we would have got -5, but this will also be -5. So that's why I use 1 decimal place because of how close they are. Now, x equal 2, let's look at that. So for x equal 2, I will have 2 take away 1 minus 5. So that will be 3 to the 1 minus 5, which is 3 take away 5 to give me -2. So I'll have a -2 here. Now I'm going to do when x is equal to 3. So replace here to be 3. So I have 3 take away 1. That's 2. So I'll have 3 squared minus 5. So that's 9 minus 5 to give me 4. So I'll have a 4 right here. Then the next one I will have is 3 to the 4. So I will put 4 here. So 4 take away 1. That's 3. And 3 cubes, that's 27 minus 5. So that will give me 22. So I'll do x equal 5. So when x equal 5, I will have 5 take away 1. So that is 3 to the 4 minus 5. So that will give me 81 minus 5, which will give me 76. Now, the next one that I'll be finding the coordinates for is y equal x squared plus 2x. So we have x squared plus 2x. I'll replace x with minus 1. So I'll have negative 1 squared plus 2 times negative 1. Negative 1 squared is 1. 2 times minus 1, that's minus 2. So 1 minus 2, that's negative 1. So I'll have a negative 1 here. Next, I'll be doing x equals 0. So where I have minus 1, I will replace it with 0. But as we know, 0 has no value. So all of this will be gone to give me 0. The next one is when x is equal to 1. So I'll replace here to be 1. So 1 squared is 1 plus 2 times 1, that's 2. So 1 plus 2, that will give me 3. So I'll put a 3 here. Next, I'll put when x is equal to 2. So when x is equal to 2, I'll have a 2 here. So 2 squared is 4, and 2 times 2, that's 4. So 4 plus 4, that gives me 8. The next one is when x is equal to 3. So once again, where I have x, I will replace it with the number 3. So I'll have 3 squared plus 2 times 3. 3 squared is 9, and 2 times 3, that's 6. So 9 plus 6, that's 15. Next one is when x is equal to 4. So I replace x to be 4. So I'll have 4 squared plus 2 times 4. 4 squared is 16. 2 times 4, that's 8. So adding this, I will get 24. The last one is 5. So I'll replace x to be 5. So I'll have 5 squared plus 2 times 5. 5 squared is 25. 2 times 5, that's 10. So this will give me 35. So on the same graph, these points must be plotted, and I will be showing you the result of this. So the first graph is 3 to the x minus 1 minus 5. So when you plot it, you use a scale that you desire. So I will have 3 to the x minus 1 as a power minus 5. This is the graph that you'll be getting. The next graph is x squared plus x. You'll be getting a parabola. Because we start at x is equal to, let's look, negative 1. So it's negative 1 is our starting point. This is what we'll have. So I'm going to cut off a part of the graph. And we stop at 5. So it will be going up further. So this is what we'll be seeing. So I'm going to decrease the size just so that you can get a clear idea how the graph looks. On your graph paper, this is what you'll be seeing. So you'll be seeing the shape like this, along with, so this purple line is x squared plus x, and this line represents 3 to the x minus 1 minus 5. But let's look at solving it. Here we're going to use the graph that we just saw to solve the following equations. Here I have 3 to the x minus 1 equal 5. First question you need to ask, does this look like the original? No, but if I carry the 5 over the equal sign, I will have 3x to the minus 1 minus 5 equal 0. So now it's looking like what we have here. So our focus is on equal 0. So we're going to look for y equal 0. Now, y equals 0 is this x-axis. So in other words, we're asking when does this graph, which represents 3 to the x minus 1 minus 5, where does it cut the x-axis? When you have y equals 0, you're saying where does it cut the x-axis? As you can see, it's this point right here. This is 2, and we're going up by 0.2 with the small lines. This is going to be 2.2, 2.4. So this means x is 2.5 because in the center. So the answer for this will be x is equal to 2.5. Part B, we have x squared plus 2x equal 10. It's looking at the original on the left-hand side. So the focus is on the 10. So we have y equal 10. So for y equal 10, once again, I'm going to the graph and I'll be looking for 10. Now the purple line represents x squared plus x. So this is the line that's going to give me the answer. So y equal 10, this is 10. You can always draw a line through here and where it cuts the curve, which is at this point, this is what I need to read off. So if this is 2, then I'm going up by 0.2. So I'll have 2.2, 2.4, 2.6, and then this is 2.7. So just remember, you can always draw a line. If you're having problems seeing where it cuts, this line represents y equal 10. So this is y equal 10 line. It cuts it. This purple line is the graph that it cuts. That's the one we're interested in, not this one. So here is where we have the intersection. And as you can see, it's 2.7. So for this, x is equal to 2.7. The final one, if you realize it's not looking like the individual functions that we drew, but if I care for the 5, I will have x squared plus 2x is equal to 3 to the power x take away 1 minus 5. So these two are equal. So if they're equal, then we're asking for the point of intersection. Where does the line and the curve intersect? So let's look for the intersection and we go further. As you can see, there's an intersection here. So we need to read off the x value for the point of intersection. This is the x-axis. So this is 3.2, 3.4, 3.6, 3.8, and then this is 3.9. So x, the point of intersection, which is the x value we're interested in, to be the solution, x is equal to 3.9. So for this, x is equal to 3.9. That's it. Thanks for watching, guys. Thanks for watching, guys. Don't forget to like and subscribe to my channel. Have a great day.